When we are solving one-step equations, we need to use our balancing method. The one step just means that there's only one thing we've got to do. So if we look at this first equation, we can probably work this out in our head, because this just means something add 3 equals 10. However, I'm going to show you how you would use the balancing method to solve this, so that you can then apply this to the harder equations. The first thing I need to do, my aim is to get the x on its own. I want to end up with x equals. To get the x on its own, I'm going to have to get rid of the plus 3. I don't want that there anymore. The only way to get rid of it is to take 3 away. But my equation has to stay like a set of scales, where whatever I do to one side, I do to the other to keep it balanced. Therefore, I'm going to need to take away 3 from the other side as well. X add 3, take away 3, will give me my x on its own. 10 take away 3 will give me the 7. And so that is my answer. X equals 7. And we can check it by putting 7 back into the equation. 7 plus 3 equals 10. My second example, I can do exactly the same. The only difference is it's written in a different order, but actually we know 19 plus x is the same as x plus 19. Addition and multiplication can be done in any order. So again, I want to end up with the x on its own. So I need to get rid of the plus 19. I have to do it to both sides to keep my scales balanced. X plus 19, take away 19, gives me my x on its own. 26, take away 19, will give me 7. So my answer is x equals 7. Again, I can check this by putting 7 back into the equation. 19 add 7 equals 26. So I know it's correct. These examples are very similar. The only difference is that I'm now looking at some negative numbers. It's minus 12. But I do exactly the same. I still want to end up with my x on its own. To get rid of the minus 12, I add 12. And I need to do this to both sides. Because x take away 12, add 12, leaves the x on its own. 16 add 12 will give me my 28. Again, check the answer. 28 take away 12 equals 16. For these examples, we are just using our multiplication and division instead of addition and subtraction. So, looking at the first example, which is 3x, I know that in algebra this means 3 times x, or x times 3. Again, like addition, it can be in any order. So I still want to end up with x on its own, which means I've got to get rid of the 3. But this time it's a times 3. So to get rid of the 3 times, the times 3, I have to use the inverse. Like for addition, I use subtraction to get it away. For subtraction, I used addition to get rid of it. So for multiplication, I'm going to use division. So I need to divide both sides by 3. 3x divided by 3 will give me my x on its own. 12 divided by 3 will give me 4. And I can check this by putting the 4 back into it. 3 times 4 equals 12. The second example, I'm doing exactly the same, but it's times 4 this time instead of times 3. So I have to divide both sides by 4. 4x divided by 4 will give me my x on its own. 20 divided by 4 will give me my 5. The last example is division. This means x divided by 5 equals 6. And to get rid of the division, I use the inverse, which is multiplication. So to get rid of divide by 5, I need to times both sides by 5. X divided by 5 times 5 will give me my x on its own. 6 times 5 is 30. Again, put it back in and check it. 30 divided by 5 does equal 6. So I know I've got it right. Have a go at these examples in your book. Pause this video to give you a chance to complete them, and then press play again to get the answers. Mark your work and see how you did. Then take your marked work to your teacher for some feedback and next steps. Well done.